Hello and welcome to our next section in our unit for triangles. I know this is 5.5, but that's because in our book, that is where this unit or this section is actually found, triangle inequality and angle side relationships. This one is not in 5.5, actually it could be, but I'm kind of just throwing that in there. So let's jump to it. Hopefully you can grab this title. Let's jump to the actual page. This is my page 26. Put this in the top right corner. And it's a really long title. And here we go. So get this settled down. Now the triangle inequality theorem. Let's start there. The triangle inequality theorem. Well, we know what an inequality is. It's usually when we have things that are less than or greater than. So that's an inequality. Triangle inequality theorem states that, well, let's break it down. We have a triangle. First and foremost, we always have three sides to a triangle. And it states that, for instance, let's call this side A, B, and then A, B, C, and then AC. They all make the sides of a triangle. Now, what happens here is this. The triangle, we could always label them like a small, medium, and large side, right? And for instance, if I called this the small side, numerically, like if they have the smallest measure, let's call this the medium measure. And then this is the largest measure. Okay, the triangle inequality theorem states that the small side plus the medium side always has to be greater than. This is very, very important. Always has to be greater than the largest side, no matter what. So if it doesn't, if not, then the triangle is not a triangle. Okay, so what happens here is this. If I put, for instance, I'm going to put this in pink. Let's call the small side 3. Let's call this medium side 8. Then we know for sure this large side has to be bigger than or less than 11. Okay, the small plus the medium has to be bigger than the large. And the way I like to think about this is this. Let's pretend you have a valley, and you need to build a bridge, right? Build a bridge. And the bridge is, for instance, 10 feet. Okay, you need to construct supports for it. And in order to construct supports for it, you need pieces that will, make a triangle. At the very least, it needs to span across it, right? And if you have pieces that are exactly equal to 10, for instance, 3 and 7, it would only lay on top of that bridge part. But if we want to support it and make a triangle, it has to be bigger than 10. So that's why the small side plus the medium side has to be larger than 10, no matter what. Okay? All right. So that is the triangle inequality theorem in order for a triangle to exist. Okay? If it doesn't fit this criteria, then it is not a triangle. Okay? So we know for sure that this has to be large and it has to be bigger than 11. Or if you have, for instance, let's say if I gave you, let's do some really quick examples. Is it a triangle? So example 1, let's say 3, 4, and 5. These are the sides. So we could say this is the 3, 4, and 5. This is the small side. This is the medium side. This is the large side. Well, we could check. Small plus the medium. Is this true? Is it bigger than the large? Well, 3 plus 4 is 7. 7 is, in fact, bigger than 5. That checks off, so this is a triangle. Okay? Now, what if we have something like this? Example 2. Let's say 3, 9, and then 6. Okay? Well, we know the small side is for sure the 3. Oops. Medium side has to be the 6. Large side is the 9. Well, 3 plus 6 is greater than 9. 9 is greater than 9. That is false. So this is not a triangle. Okay, it has to be greater than. Now, the other part, so that is triangle inequality. Now, the other part to this lesson is angle side relationships. And if you have angle side relationships that we, in a triangle, we're talking about how does the side relate to its corresponding angle and vice versa. So if I drew another triangle, so this is side angle relationships. If, for instance, we drew a triangle, and let's call this XYZ. Okay, so triangle XYZ. Now, if, for instance, I said, well, here, this is the foundation for it. Every angle is directly related, or correlates, I should say. That's a better way to put it. Correlates to its opposite side. And vice versa. What I mean by that is, if I have a side, let's say for instance, let's talk about angle X. X directly correlates to its opposite side, which is YZ. And vice versa. If I'm talking about YZ, the side YZ directly correlates to X. Okay? So those are kind of paired off. That's how you always view it. Opposite angle, the angle to its opposite side, or side to its opposite angle. So if we're looking at this triangle, okay, so as we mentioned, angle X is opposite to YZ. Angle Y is opposite to XZ. And then angle Z is opposite to XY. Now this is an important relationship that they have because, this is an important relationship they have because the longest side is always opposite to the longest angle, or largest angle. So this is important because the longest side is always opposite the largest angle. The medium side, oops, this is supposed to be longest side. The medium side is always opposite the medium angle. And the smallest side is always opposite the smallest angle. Okay, so for instance, if I took this diagram and I just start putting in some measures, and I'll just do this in pink. If I said this was 10, 12, and 14, then we could with confidence say, so this is the smallest side, this is the medium side, this is the largest side. The opposite side of 10, or the opposite angle of 10, would be Z, and that would be the smallest angle. The opposite angle of 12 is X, which would be the medium angle. Okay, and then the largest angle would be opposite the largest side, which would be Y, and vice versa. Okay, so that is important to kind of break apart. If you do have any questions on this, please bring them to class, and I will see you in the next one. Bye.